Hey guys, what's up and welcome to the Phil Studio. Today is a great day because I'm presenting to you probably the coolest homemade dual polarity variable power supply. So today is just a show off and a little tour around the power supply. If you want to see a little bit more about the process and how I design it, I have 4 videos online of this and you can find them in the description of this video. So let's go. Here we have a simple front panel with two 8-segment display. I'm going to show you in a sec. We have two knobs to adjust the positive voltage as well as the negative voltage, and a switch to trigger on off these supply. So we have a ground here in the center, the positive, which is red, and these segments are also red, and a green for the negative voltage, and the segment are also green. Here we have 3 other plug. This is a clean 12 volt, the ground, and as well as a fixed 5 volt. This is good to power up some digital stuff, Arduino, or anything that works with small voltage, 5 volt. And this 12 volt is a 1 amp maximum power. These are 1.5 amp. What is really nice is here on the side. You have like a weird knob here and a jack connection. So mainly this power supply I decided to design to work with a breadboard like that with 2 jack connection, which will really ease the process of designing audio effect, synthesizer, oscillator. And this is why I have this 1/4 connector here. It served as an input for audio, or my guitar or audio effect I'm working on. And we have the volume control. This dual polarity variable supply includes a cheap 5 watt or 10 watt amplifier. In the back we have connection terminal to the speaker. This is really convenient. We have a spare fuse here, fuse holder, 3 amp maximum power. We have the AC connection, and then a switch with a big lamp on the top. So when you power this up, the circuit is powered up. This means that you have your 12 volt here and your 5 volt here already. And by default, the amplifier is open. You can see the blue LED inside. It's light up. That's really nice. Oh yeah. So why don't we power up these main supply? So the knob is turned like to the minimum currently, so we have 0 volt, and it's not enough to power up the display. So I'll just turn it slowly, and we should start to see the voltage appear. The LM317 and 337 are 2 regulators that can handle up to 30 volt DC output. Unfortunately, the transfo on my main power supply was not big enough to provide enough voltage, so the maximum voltage currently is 16.2 volt, which is not a problem for me because I'm not going to work with more than 15 volt positive and negative. So I'm gonna turn up the negative voltage. So you can see that this is really precise. I can go like to 6.31 volt. I don't know why I would do that, but it's possible. And for those who want to know if the voltage is precise on this little gadget, well, I'm going to show you with my voltmeter. Positive probe, positive in, out, and the ground here. So I can read 9.32. 9.29. So we have 0.03 voltage difference, which is not that sad. I'm going to keep the reference here and plug the positive here. So I would be supposed to read 9.54 minus 9.54, and here I have, oops, excuse me, minus 9.59, which is pretty good. It's pretty precise. And if you're crazy, you can double the voltage by using the negative swing or the negative output and the positive outputs, and you get the sum of both, which is 18.91 volt. Really nice. That's about it for the external of my power supply. Since you're really lucky today, I'm going to open up the box and present you like the layout. Opening the box is really easy. You have 6 screws, and then you can just open the top. So we gotta be careful because there are some wire connected there, but everything is planned out and you have space to work safely. So we have the AC connection, the fuse. This is the main power input. There's some connection to the switch and the light. Then the neutral and the live goes into this transformer, which provides something like 28 volt AC with a center tap. This is how I can manage to have the positive and the negative output. Here we have a full bridge rectifier, and we have the first like really custom board. Here I have the 12 volt regulator, which goes to the 12 volt. I have the 5 volt regulator, which goes to the 5 volt, and here we have another 12 volt, which provide the power to this little amplifier here. So the amplifier as is independent source of power. Everything is fixed with screw, so it cannot slip. The big transfo is screw as well as the main power board and the AC connector. And then we come to the nice part, which is the board I did myself and drawn and etched at home. So if you're interested, you can find all the process of the making of this board. There's 3 videos linked in the description of the video, so you get to know how I managed to lay out this. And there's also one video on me trying to do my best at drilling a nice hole for the display here. It wasn't easy, but I managed to do a clean job. You can see there is just a little tiny part here and here, imperfection, but though it looks great. And you can see on the top panel my 4.7K variable resistor potentiometer with the switch. So that's mostly about it. I'm gonna give you a top view of all the layouts so you can have a good idea of how it was made. The wires are pretty long, but this just give me the chance to work on it if I have to open the board, and I haven't had any noise problem yet. Everything is filtered with big capacitor and stuff. This is a great gadget, and I'm excited to see like your homemade power supplies. Don't be shy to comment and share the videos of your stuff. I'm curious to see what you've done. So that was a tour of my homemade, truly homemade power supply. I'll see you guys around because I have many more homemade gadgets coming soon. See ya!